So this is just one more way they might ask you to take a derivative. If you see d over dx with brackets and then something on the inside, it means take the derivative of this expression. Okay? So in this particular case, it is like, although it's not written, it's like f of x equals the square root of x plus 1. So if we use that limit definition of a derivative, we're going to have f of x plus h minus f of x all over h. So for this problem, the x plus square root of x plus 1 goes here for your f of x. For f of x plus h, you don't necessarily have to write this, but you're just replacing x with x plus h, so it just looks like this, x plus h plus 1, like that. So that goes here. And what we end up with will look like this. Limit as h approaches 0 of the square root of x plus h plus 1 minus the square root of x plus 1 all over h. And if you plug in 0 right now, you will get 0 over 0, so we are not done solving this limit. What are we going to have to do? We cannot square the top and bottom. We have to multiply by the conjugate. So we are going to multiply by square root of x plus h plus 1 plus the square root of x plus 1. And when we do that, we have to multiply on the top and the bottom. Like that. So when we distribute here, square root of x plus h plus 1 times square root of x plus h plus 1 is going to give us x plus h plus 1. And then we will multiply like the outside terms and the inside terms, and they would be very complicated if we multiplied them together, but they're going to cancel each other out. And that's the reason you choose the conjugate every time. And then you're going to multiply square root of x plus 1 times square root of x plus 1. That's going to give you x plus 1, but keep some parentheses here because it's negative x plus 1, and you're going to have to distribute that negative. And this will be over h times square root of x plus h plus 1 plus square root of x plus 1. Let's keep that limit notation. We're okay here? All right. Then I can distribute this negative right here. It's going to make that x right there negative. It's also going to make that 1 right there negative. And you're going to have some stuff cancel. So x and x cancel, and 1 and negative 1 cancel. So that is going to just leave us with the limit as h approaches 0 of the only thing left on top is h. On the bottom we've got h times square root of x plus h plus 1 plus square root of x plus 1, like so. And what can happen now? Okay, the h's are going to cancel. We do need to keep a 1 on top to hold our place, which Joshua has learned his lesson on, I think, from the last FRQ quiz, right? Was that you? Yeah. We've got 1 over square root of x plus h plus 1 plus square root of x plus 1. And we're going to plug in 0, so it is going to give us 1 over square root of x plus 0 plus 1 plus square root of x plus 1. This is going to be 1 over the square root of x plus 1 plus the square root of x plus 1. What is the square root of x plus 1 plus the square root of x plus 1? Perfect. 2 square root of x plus 1. And that's typically how the answer will be left for that. Okay, questions? All right, let me see here. Okay, so we worked on point slope forms a little bit the other day whenever we were doing that like investigation. But it's just a way of writing the equation of the line that I want us to use in this class. You can use y equals mx plus b, but you're more likely to make a mistake, right? So, so this example right here is just a point slope form problem. This is a math 1 problem. It is not a calculus problem. Write the equation of a line that has a slope of 4 and passes through 6, negative 2. So if I want to do this, I'm just plugging into this equation. So this right here would be my m, and it would get plugged in right here. And then this point, the 6 right here, that's my x1. So it gets plugged in right here. And then the negative 2, that's my y1, and it gets plugged in right here. So when you have to do something like this, you can just write the equation right away. Y equals 4, parentheses, x minus 6, minus 2. And on any type of free response question, we just want to leave our answer like that. Yes, you could distribute the 4, combine like terms, make it like y equals mx plus b, but there is no benefit to doing that if they just asked you for the equation of the line. This is an equation of the line, and you might mess up if you try to simplify, so you could just leave it like that. Okay, now let's look at where this is going to come in for the calculus problems that we're going to see. So our equation now says, our question says, write the equation of the line, tangent to f of x equals the square root of x minus 2 at x equals 3. Okay. Now, this did not ask for the slope of the tangent line. It asked for the equation of the tangent line, right? So, slope of the tangent line, that is just the derivative. Equation of the line tangent, or of the tangent line, we have to find derivative and then use point slope. Yes, correct. So for point slope form, you need 2 things. You need a point and a slope. The point is the easiest one to find. So if I want to find the point, what do I have to do to find the point on the graph, that point of tangency? What? F of 3 is exactly what we need to do. Make sure when you do this, you label it. F of 3 equals square root of 3 minus 2. And that's just going to be square root of 1, which is 1. Okay, so our point, f of 3 equals 1. That means our point 3,1 is what's called the point of tangency. That just means that single point where it barely touches the graph. Okay, so the point, sometimes the point's given to you, but the textbook, for example, gives you the x and the y coordinate on the point, so you wouldn't even have to do that step because it's given to you. But for this, you only have the x coordinate, so you got to plug it in to find the y coordinate. Then, to find the slope, you need the derivative. which definition do we need to use here to find the derivative? Okay, this one we can use f of x minus f of a over x minus a, right? We can use the one we were using at first. Or you can use the x plus h if you prefer, and then plug in the number 3. Either one works. I prefer the f of x minus f of a over x minus a if it works, because I think it's usually a little bit easier to do. So I think I'll use that one here. So for our slope, we want to do the limit. Actually, I'm going to label it. I'm going to call it f prime of 3. So it is the derivative at 3. And I'm going to say the limit as x approaches the formula we're using. I'm going to write the formula with the a's in it here just so you guys remember which one we're using. It's not necessary to write this whenever you're doing the problem, but f of x minus f of a over x minus a.
So when can you not use that?
If there's not a specific point that it's asking you about. So like on,
so like
yeah.
X
Yeah, so that at x equals 3 means we can use this. But if they're not asking you about a specific point, you're going to have to use the x plus h rule. So for this, we've got f of x that goes right here. We actually already have f of a, right? Because it would be 1, and I just marked right through it. Let me see if I can, let me fix that. That goes right here. We found f of a, that goes right here. What is the a? 3. So that 3, it goes right here and right here. So we're going to have the limit as x approaches 3 of the square root of x minus 2 minus 1 over x minus 3. Okay, currently, if you try to plug in numbers, you're going to get 0 over 0. What should we do? Conjugate. We're going to multiply by the conjugate. Square root of x minus 2 plus 1. We got to multiply by that on the top and bottom.
Is that like a common thing when you have square roots? You have to do the conjugate?
Most of the time. Alright, so when we distribute here, square root of x minus 2 times square root of x minus 2 is x minus 2. The outside and the inside part cancel, which is why we chose the conjugate in the first place. And then you got to multiply negative 1 times positive 1, which is just going to give you a negative 1. And then make sure you're putting parentheses around this in the bottom. It's x minus 3 in parentheses times the parentheses x minus 2 underneath the square root plus 1. If you don't have those parentheses, it's going to look like only the 3 is supposed to be distributed, and things can't really cancel there. Now, in that numerator, what am I going to get? X minus 3. Is it all right with you guys if I just erase this and make it a minus 3 so I don't have to rewrite all that again? We're going to make that a minus 3. Then the minus 3's can cancel, right? What goes in that numerator? 1. We're plugging in a 3 for our x, so square root of 3 minus 2 plus 1 is going to be square root of 1 plus 1, which is just 1 plus 1, which is 1/2. So we've got our point, we've got our slope. The last thing is to write your equation of your tangent line. And the point-slope formula makes this so easy. I'm going to write down point-slope formula just one more time because I know it's kind of new for us. Y equals m times x minus x1 plus y1. And so we found our slope. It goes right here. We've got our point. We've got our x1 goes right here. Y1 goes right here. So you're just going to have y equals 1/2 x minus 3 plus 1. And this would be your final answer. You could distribute it, you could simplify it, but don't, because you might mess up, and if you mess up, then you'll lose that answer point there. Okay, questions? All right, let's see. Okay, these are important for us to look at because these are not questions where you're really going to like do a lot of work, but you still need to be able to find the answer. So this shows f of x in the table, gives select values of the derivative of f. Write the equation of the line tangent to the graph at x equals -1. Then graph the tangent line on the graph above. Okay, so we're looking at x equals -1. X equals -1 right here on the graph. To write the equation of the line tangent, we need 3 things. Just like the last problem we did. We need a point, we need a slope, we need the equation of the tangent line, right? So for the point, what is our point for this? -1, -6. Okay, what's our slope?
How do you know that -1, -6?
I'm just looking at the coordinates of that point on that graph. So it told us x equals -1, which is right here,
yeah.
and I'm just looking at the points on the graph. Okay, what's my slope? All right, it is 4. Where'd you get it from? It is right here because f prime gives you slope, right? So the derivative gives you the slope at that point. The slope is going to be 4 because f prime of -1 equals 4. So when you have a point and a slope, you just need to use that point slope of an equation. Y equals 4 times x plus 1 minus 6. That sign changes because when you have a minus a -1, it becomes positive. So I like those because it's very minimal work that you have to do on those. All right, let's see what else we've got here. I'm not going to do a normal line. Our book asks us about a normal line, but I don't think we really, I don't think they put that on the exam anymore. All right, let's do this one. This is as difficult as it's going to get for us. Find the equation of a line that is tangent to the graph of f of x equals x squared plus 4 and parallel to 2x plus y equals 8. Let's see. I know we're not sure if we're going to get to use Desmos or not, but right now we're at least trying to operate like we won't get to use Desmos. So let's look at it anyway, because looking at it graphically sometimes is helpful. All right, we've got f of x equals x to the second plus 4x. So we're looking at this graph, and we're looking for a tangent line that is parallel to 2x plus y equals 8. So let's think of it this way. I'm going to do, like, I'm just playing around with Desmos right now for you to get a picture of what we're looking at. This line right here, 2x plus y equals 8, could I just, like, subtract that 2x right here and say y equals negative 2x plus 8? Is that the same line? Yeah, to prove it, if I go over here and type it in, y equals negative 2x plus 8, if I graph it, the same line that I already have, right? So if a line is parallel to that, what has to be true about the other line? Same slope, right? So like if I type in y equals negative 2x, that line's parallel to the green line. Is that going to be your answer? Is that purple line a tangent line to your graph? It is not. I'm going to put a plus a right here. Put a slider, okay? So now I can slide this up or down. All of these lines are parallel, right? So if I'm looking for the tangent line, I think it looks like it's going to be about right here. I think it looks like it's going to be that line, right? But we are not going to be able to put sliders in on the AP exam as far as I know. If that changes, then we'll change what we're thinking here. It looks like that point of tangency is probably going to be at -3, -3, maybe, or somewhere around there. And it looks like, like y-intercept ends up being like -9. So that's what it looks like. But if they give you this problem, they're probably going to give it to you without a calculator. Even if you get to use Desmos, this is probably going to be on the calculator inactive section. So you're not going to get to use Desmos even if they do allow it. So I've got to figure out what to do for this equation of the line. To write the equation of a tangent line, I need two things. I need slope and I need the point. Which one of those do I already have? I've actually already got the slope, right? Because this right here is the slope of this line. The derivative is going to have to be equal to that. So I've got to work backwards on this. I need to find the derivative and see where it would equal -2. All right. So since I need to do that, I don't have a point to look at. I have to use the x plus h definition in this case. So I'm doing the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm going to plug this in here. I need to find f of x plus h. I think I'll just do it within the problem on this one. It's not too bad. So f of x plus h is going to be x plus h squared plus 4 times x plus h. So that piece right there is this right here. Then I need to do minus x squared plus 4x, all of this over h. Okay, here. All right, we're going to keep going. Let's square double square here. That's going to give us x squared plus 2xh plus h squared. And then I'm also going to distribute that 4 plus 4x plus 4h. And I'm going to distribute this negative minus x squared minus 4x. All of that is over h. And we don't want to drop our limit notation. So we'll do this. And the x squareds are going to cancel. Plus 4x and negative 4x, those are going to cancel. Everything I have left has an h with it, so I'm going to factor one out. So h times 2x plus h plus 4 all over h. Limit as h approaches 0. H's will cancel. I will plug in 0 for h. 2x plus 0 plus 4 is just going to give me 2x plus 4. Okay. All right, so that's all of that work to get the derivative, right? This is f prime of x that we just found right here. It's our derivative. My derivative tells us the slope of the tangent line. So 2x plus h gives us the slope of the tangent line. We want to see where 2x plus 4 equals negative 2. So we're going to set those equal to each other. So we're going to say negative 2x. I'm sorry, I don't know why I'm doing negative 2x. It's 2x plus 4 is going to equal negative 2. And that is a very simple equation for us to solve. We're going to subtract 4. 2x equals negative 6. We will divide by 2. X is going to equal negative 3. That is our x coordinate of our point. How do we find the y coordinate of the point? We got to do f of negative 3 and x squared plus 4x. So that is going to give you 9 minus 12, which will give you negative 3. So your point is going to be negative 3, negative 3. And so finally, you are going to be able to write the equation of your tangent line. So equation of your tangent line is going to be y equals, what was it, negative 2? Yeah, negative 2. Negative 2 is your slope. Because the slope of this line they give you right here would be negative 2. So negative 2 times x plus 3 minus 3.
Do we define the derivative in order to plug in those two to get the points?
Right.
Okay.
So we already had the slope. We knew the slope was supposed to be negative 2 because that had to be parallel to that other line that we had. So we weren't really finding the derivative to find the slope in this case like we've done on most of the other problems. We had to find the derivative so we could set it equal to the actual slope and figure out where the point happens for that. So that this one's kind of backwards. And if I flip over to Desmos,
Without Desmos, how are we supposed to know if the slope is negative?
just because this line right here, if you have any line, if you solve it for y, it's going to be y equals mx plus b form. So the number next to your x is your slope. Yeah. And if
F prime is negative 3, but it's negative.
2x plus 4 is your derivative. If you plug in negative 3, you will get negative 2. And that is also your slope. Yeah. So you could do a step where you find like f prime of negative 3, but we already know it's got to equal negative 2 because that's like how we set it up in the first place. So if you did that step, it'd be fine, but it's not really necessary for that. And if we graph it, it looks like it's supposed to. That's the right line right there. So that one's the most extensive that you will see there. For now, things will get crazier eventually. That's a pretty good looking problem there. There's a lot going on. All right, so let me look at this assignment. I may decide to change a couple things because we didn't do everything I wanted us to do last night. So let me see. We got. I think this will be okay. I don't think there's anything I need to add. These are all equation of the tangent line problems. So there's not any here that will just ask you for the derivative. You'll have to find the derivative, find the point, find the equation of the tangent line. These last two right here, 34 and 36, they are like the last example. Okay, so they're like that last example that we did. All right, so we actually have a little bit of time to work. Hopefully you can get several of these